Well, hi everyone. We are just going to go over this review sheet that we did in class. And these first part deal with the complex numbers. And if you'll recall, when we had a number like this, we always factored out. If it was negative under the radical, we would factor it out. And we had 9 times 5, and then we'd do a factor tree here. And then we're looking at the square root of negative 1 times 3 times 3 times 5. And that is the square root of negative 1 times 3 squared times 5, which is the square root of negative 1 times the square root of 3 squared times the square root of 5. The square root of negative 1 is I. Square root of 3 squared, those cancel each other out. That is 3, and the square root of 5 we can't do much with. So the last part of that I'll write as 3 radical 5 I. Okay. I'll circle that. Now the next one here. I've got negative 1 times 10, and I'll break 10 down as 2 times 5, and that's all the further we're going to get with that. This is negative 1 times 24, and I'll break down that as 8 times 3, which is 4 times 2, which is 2 times 2. Okay, and then I'll do each one separately here. So I've got and then I'll put them together. I got the square root of negative 1 times 2 times 5 times the square root of negative 1 times 2 times 2 times 2 times 3, 2, 2, 2, and 3. Okay. And this is the square root of negative 1 times the square root. I'm going to keep the 2 times 5 together, and I'm going to take the square root of negative 1 out of here. And for right now, I'm going to keep these together because I do want to put them together. I want to put this together with this. So the square root of negative 1, that's I here. Square root of negative 1, that is I here. And then I have the square root of, and I'm running into this next problem here, I'll put the 2 times the 5 times the 2 times the 2 times the 2 times the 3. Let me come up here. I don't need much room for that one. And that's I squared. I times I, that's I squared. And this is the square root of 2, 2, 2, and 2. So I'm get as many squares as I can here. There's 1, there's 2 squared, and then the 3, and then the 5. So that's negative 1. That's negative 1 times the square root of 2 squared times the square root of 2 squared times, I'm going to make that the square root of 15 since I can't put that together. So it's negative 1 times 2 times 2 times the square root of 15. Negative 2 times 2. That's negative 4 radical 15. So that's my final answer on 2. Number 3. Negative 3 times 5 is negative 15. I times I is I squared. So that's negative 15. I squared is negative 1. Negative 15 times negative 1 is positive 15. Negative 3i times 5i is positive 15. Now, 4 is an addition of complex numbers. I'm going to add the real parts, the 2 plus the 5, and then the imaginary parts, negative 3i plus I. 2 plus 5 is 3. Negative 3i plus 1i is negative 2i. And that's in A plus BI form, which is what I want there. Number 4, I'm going to do the same thing. I got 4 plus 5, nope. Yeah, well, let me get rid of parentheses first. 4 plus 5i minus 3, and minus minus makes a plus 2i. So I got the 4 minus the 3, plus the 5i plus the 2i, and 4 minus 3 is 1, 5i plus 2i is 7i. 1 plus 7i. Now, 6 is a multiplication problem, so I'm going to multiply. 8 times 11, 88. 8 times negative 10i, negative 80i. 9i times 11, 99i. And 9i times negative 10i is negative 90i squared. All right, well, what do we got here? 88, negative 80 plus 99i is, I think, positive 19i. 99 minus 80 is 19. Minus 90 times negative 1, because I'm taking the I squared out and putting negative 1 in its place. So we got 88 plus 19i plus 90. Let's add the 90 and the 88 together, and that's 178 plus 19i. And then on division, I am going to multiply the numerator and the denominator by the conjugate of the denominator. And that's how we're going to make this real, the denominator real. And so let's FOIL this first part first. 1 times 3 is 3. That's first. Outside, that's negative 4i. Inside, negative 6i times 3 is negative 18i. And last, negative 6i times negative 4i is positive 24i squared. And then 3 times 3 is 9. Outside, that's negative 12i. That's 3 times negative 4i. 4i times 3 is positive 12i. And then last, 4i times negative 4i, that's negative 16i squared. And this is why it works, because those two cancel out there. Let me simplify the numerator some more. That's 3. Negative 4i and negative 18i is negative 22i. And then I'm taking the I squared out and putting negative 1 in its place. And I'll simplify that in a minute. And then I'll do down here 9 and then minus 16 times negative 1. And that's 3 minus 22i, and 24 times negative 1 is negative 24. And then that's 9 minus negative 16. Just doing one step at a time, numerator, denominator. 3 minus 24, I got negative 21 minus 22i. 9 minus negative 16 is 25. That's 9 plus 16. And then when I write it in a plus bi form, I got negative 21 25ths minus 22 25ths I. All right, next, number 8. X squared plus 14x minus 29 equals 0. And I'm going to complete the square. I'm going to add 29 to both sides first. So I have x squared plus 14x plus blank equals 29 plus blank. All right. Remember, we got to go b, which is 14, over 2 and square that, and that is 7 squared, and that is 49. So I'm putting 49 here, 49 here, and the binomial squared that's made by adding 49 is x plus 7 squared, and 29 plus 49 is 78. And I'll rewrite that, because now I want to take the square root of both sides, and I have a positive and a negative square root. The square and the square root cancel out, so that's x plus 7. And that's positive or negative square root of 78. I do happen to know, 78, if I break it down, that's 39 times 2, and that's 3 times 13. So there's no simplifying that's going to happen. I'm just going to leave that as a square root of 78. So I'm subtracting 7 from both sides. I've got x equals, it cancels, negative 7. Let me write that part first. Plus or minus the square root of 78. There's two answers. Negative 7 plus square root of 78 is one of them. Negative 7 minus the square root of 78. Remember that plus minus is a shorthand way of writing both solutions. All right, number 8. We are using the quadratic formula. I'll write that down. X equals negative b plus or minus a square root of b squared minus 4ac. All of that over 2a. And I'm going to add 9 to both sides. 2x squared minus 11x, negative 4, 9, plus 5 equals 0. A is 2, B is negative 11, and C is 5. And x equals, now negative b, or the opposite of b, if b is negative 11, I write positive 11 out here. Plus or minus the square root of negative 11 squared minus 4 times 2 times 5. That's the 4ac. All of that over 2a, 2 times 2. So, I like for you to figure out what this is. And I think you're going to get 121 here. 4 times 2 is 8, times 5 is 40. Okay. Let me just do that calculation real quick. All right, so what do we got? We got negative 11 squared minus 4 times 2 times 5. That's 81. Okay. That's a nice number. Over 4. And because the square root of 81 is 9. And so I have 11 plus 9 over 4. Or I have 11 minus 9 over 4. And if it's a 11 plus 9, that's 20 over 4, which is 5. Or 2 over 4, which is 1/2. So those are our two solutions, 5 or 1/2. So that's good there. Now, next one, x squared minus 3x plus 9 equals 0. A is 1. B is negative 3. C is 9. And x is positive 3. Plus or minus the square root of negative 3 squared minus 4 times 1 times 9 over 2 times 1. which is 3 plus or minus. This is 9. 4 times 1 times 9 is 36. 9 minus 36 is negative 27 over 2. Well, let me look at the square root of negative 27 real quick. That's negative 1 times 27. That's 9 times 3. And that's 3 times 3. Okay. So that's square root of negative 1 times 3 times 3 times 3, which is negative 1 times 3 squared. Got two of them here, times 3. Square root of negative 1 times square root of 3 squared times the square root of 3. That's I. That's 3. And that's the square root of 3. So 3 radical 3 I. So that's 3 plus or minus 3 radical 3 I over 2. And then I'm going to write 3 over 2 plus or minus 3 radical 3 over 2 I. Okay, there's number 9. Number 10. Describe the solutions you got for number 9. And I have a word bank here. We're going to say rational solutions, irrational solutions, imaginary. I'm also going to say how many. I've got 2 imaginary solutions. And one of them is 3 halves plus 3 radical 3 over 2i. One of them is 3 halves minus 3 radical 3 over 2i. What is the value of the discriminant? That is the part under the radical. That's the b squared minus 4ac part. Is negative 27. Now what about the discriminant led you to the answer you got in part A? What about that led to this? Okay? If the discriminant is negative, and that's the big thing here, if the discriminant is negative, then you have 2 imaginary solutions. Okay. Now, if this has said number 8, the discriminant's 81, what about it would lead me to the answer? I would say something like, if the discriminant is positive in a perfect square, you would have 2 rational solutions. Or if it's 0, for example. If the discriminant's 0, you're going to have 1 rational solution. If the discriminant is positive but not a perfect square, you say 2 irrational solutions. So that's kind of what you do there. If the discriminant is, if the discriminant is 0, describe the solutions. You would have 1 rational solution if the discriminant is 0. Because you're adding the square root of 0 and subtracting the square root of 0, which will going to be the same thing either way. All right, number 11. We're going to write this function in vertex form. I'm going to factor out the negative from x squared, put the negative on the outside, and the negative, I'm going to put it on the outside for 8x, so that makes positive 8x. I'm going to complete the square here. I've got minus 13. Now it's a negative here, so I'm going to go positive when I add here. Okay, it's a negative because it distributes. Even though you see the plus there, it's a negative. And then that's b over 2 squared, which is 8 over 2 squared, which is 4 squared, which is 16. So 16 goes here, and 16 goes here. And when I write this in a binomial, that's x plus 4 squared, negative 13 plus positive 16 is positive 3. Okay. I do know with this negative, the graph goes like that. So it has a high point. It has a maximum. The equation for the axis of symmetry, we've got it in vertex form now, would be x equals negative 4, the opposite of positive 4 there. The coordinates of the vertex are negative 4 and 3. The y-intercept, sometimes it's easy to just go to the very first one that you had. When x is 0, you got negative 0 squared, negative 8 times 0, and minus 13. When you have this one, you can write this out. Negative 0 squared minus 8 times 0 minus 13. You just put x 0 and calculate. And then you've got 0, 0, and negative 13. The y-intercept is negative 13. The domain, let's get the thing, let's plot it while we're at it here, and then we'll answer domain and range. I see the vertex is a good place to start, is negative 4, 3. All right. I'm curious what would happen at negative, let me put negative 5 here, and negative 3 here. This is x, and this is y. I already knew the negative 4 and the 3. So if I put negative 5 in this, I'm going to put it up here in that one. You got negative 5 plus 4. You're going to square that, and you're going to add 3. That's where the x was. And that's a negative 1 squared plus 3. And that's negative 1. Negative 1 squared is 1. So that's just negative, and this is 1 plus 3, which is 2. Now, due to the symmetry of this thing, I could cheat, but I'm going to actually just work it out with negative 3 plus 4 squared plus 3. Plugging a negative 3 in for x now and calculating and putting the answer here. That's 1 squared plus 3. And I still have that negative out here. I forgot about that. Which is negative 1 plus 3. Again, that is 2. I'm going to put negative 2 in. I said do at least 5 points. And I'll put negative 6 in. I think these two are going to be the same, so I only need to do 1. So negative, and then negative 2 plus 4 squared plus 3, which is negative, and then 2 squared plus 3, which is negative 4 plus 3, which is negative 1. Negative 1 here, negative 1 here. All right, that's enough to plot. Negative 6, negative 1. 4, 5, 6, negative 1. Negative 5, positive 2. Did that one already. Negative 4, 3. Negative 3, positive 2. Negative 2, positive 1. All right, got a nice little parabola here. The domain is the domain for all quadratic functions, negative infinity to infinity. And the range, notice it has a high point. The low point, there is no low point. So we'll put negative infinity there, and it gets to its high point of 1, 2, 3. 3, and 3 is included. That's a solid circle, so 3 is included. All right, that is that.